Chapter 2.1, we get into more polynomials. Today will be a lot to do with the quadratic function. We reintroduce the vocabulary word degree. It simply is the largest exponent within a problem. So example 1, they're sort of hiding the 7 right there. So this would be a degree of 7. And this one down here, the largest exponent is that 3. And so you'll notice the difference between example 1 and example 2 is the order is slightly mixed up. In that first one, we would write negative 4x to the 7th first. Then there's a 6x to the 4th. Then 3x squared plus the 2x plus the 3. So it's in what we call descending order. Then we have a few more examples. The degree of polynomial 0 is a linear function. We just got done looking at those in chapter 1. This would be like 3x plus 2. A degree, or excuse me, that's down here. So the 0 function is a constant. That's just simply y equals 5. This is the linear first degree, so you'll notice it's y equals 3x to the first power plus 2. I really don't need to write the 1, so just first power. So 3x plus 2. And then what we're going to kind of look at today is quadratic. So things that have x squared. You can go into the online textbook and look at an example of this. So with standard form, we're going to do some completing the square. So general form is what we talked about with linears even. We put it all equal to 0. And standard form, or this vertex form right here, we're going to be able to tell what the vertex is, the maximum or minimum. Remember, there'll be a line of symmetry running down the middle. If the a value in front is greater than 0, which means positive, it opens up. If it's a is less than 0, which means negative, it opens down. So we're going to do an example of completing the square. All right, so the first thing I like to do is make sure that my leading coefficient, the leading coefficient is what's in front of x. I want the leading coefficient to equal 1. It is. At the same time, we're going to move this 14 further down in the problem. So keep your x's together. So it looks something like this, x squared minus 8x. We're going to add a new number. We're going to add a new number so that I can factor this easier. So I take my negative 8, which is the b value. I divide by 2. I get negative 4. I would like you to put that in parentheses because we're going to square it. And we're going to use that negative 4 later, which would be 16. So I'm going to add a new 16. You are not allowed to just add numbers to somebody's equation. So you were taught long ago to put the plus 16 over here, but there's nothing happening over here. So it's really going to be on this side. And if I move it to this side, it's like subtracting 16. So what you'll notice that right here, these numbers add up to 0. So mathematically, I've not done anything to the problem. Now, the nice thing is, this right here factors into x minus 4 and an x minus 4. But I'm not going to write it that way. I'm going to write it x minus 4 quantity squared, and then these two things add up to negative 2. But even if you have a hard time factoring, what you'll notice is this number that you put in parentheses is the one that goes right there. So now I know there's a positive 1 in front, so it's an upward opening parabola, and it has a vertex at 4, negative 2. So it's always exactly what you see for the x, or opposite of what you see for the x, exactly what you see for the y. The next example is a DIY, so look at example 2, try that on your own, and I'll put the answer up. All right, so in example 2, your answer is x plus 7, quantity squared plus 1. You would move the 50 further down in the problem, take the 14, divide by 2, you get 7, put that 7 in parentheses, square it, you get 49. So when you add 49, you also have to subtract 49. So that's how you got that. So remember, the 7 is positive right there in parentheses, goes right there. So now we are looking at an example where the leading coefficient is no longer a 1. So again, we'll start by moving the 12 further down in the problem. So I look at these two numbers. I have to factor out the negative 2 from the x squared. But I also have to factor it from the 4. So 4 divided by negative 2 is negative 2x. Then we add some new number. We have our 12 here, and further down.
Good morning, staff. If you have senior...
So off to the side, I take this negative 2. It's my new b term. B. So I take the negative 2, divide by 2, I get negative 1. Put in parentheses, square it, I get 1. This time when I add 1, I would normally subtract 1, but notice what's happening. Because we had to factor that 2 out at the beginning, I actually have changed my problem by negative 2. So I will add 2. So now it looks like a negative 2 in front, something squared, plus 14. Well, the variable is x. Variable is x. And I have a negative 1 right there. That's what goes in parentheses. So now this one is an opening down parabola and a vertex at 114. So again, next one's a DIY. Try it on your own. We'll put the answer up. So here's the answer. It has a vertex at negative 2, negative 23. It's opening up. But you take the 5 out of both the x squared and 20x term, leaves the 4. Off to the side, you would have taken the 4 and divided by 2, and you would have got positive 2 right there. But don't forget about these two. When you put that 4 in, that's 20, so that's why you subtracted 20. All right, the next examples 1, 2, 3, 4. They're all DIYs, so if you want some more practice, pause the video now, practice those 4, and then come back and look at the answers. So you can see the 4 answers and some of the work. So if you complete the square technique, that's what you should get. Over here, if you're writing it as a fraction or a decimal, I guess it doesn't really matter. But if you have any questions on those, please see me or your teacher. The x-intercepts of a quadratic function can be found by factoring and doing other things. We can find them by completing the vertex or completing the square and solving it. right away I can tell this is an opening down parabola. Now, if I were to factor this, this is a little bit more difficult because of the negative in front of x squared, but I could go negative x and x, and I need two things that multiply to give me negative 8, but they have to add up to the 6 in the middle. So we could do I think if we do something like 2 and 4, if I make this one positive and this one negative, negative x times x is negative x squared, 2 times negative 4 is the negative 8, but here I get 2x, yep, here I get 4x, that adds up to 6x. So this would be the correct factoring, which means my x-intercepts would be negative 2 if you solve that first one, and 4. Now, if I find the vertex by completing the square, I would have to take out the negative, leaves behind x squared minus 6x plus some new number, push the negative 8 further down. I would take my negative 6, divide by 2, and get negative 3, square it, and get 9. So if I add 9 on the dotted line, though, I have now negative 9, so I need to add 9. So my vertex form would look like negative x minus 3 quantity squared plus 1. Now I can verify my x-intercepts by solving this. So if I set this equal to 0, subtract 1, divide by the negative, subtracted 1, negative 1. Now divide by negative 1, I get x minus 3 quantity squared is equal to 1. If you square root, you have to remember your plus or minus. So plus or minus 1, and now add 3. So what's 3 plus 1? That's 4. And what's 3 minus 1? That's 2. So now when I look back, I had solved this first one, I got negative 2. So what I'm able to do now is see what was my mistake. So I can do negative x plus 2 is equal to 0. Subtract the 2 on both sides. Now I have negative x is equal to negative 2. Divide by negative 1 on both sides, and I get x is 2. So now you can see that these two things are actually the same. So if you ever struggle with your factoring, you could always use the complete and square technique to go ahead and find your zeros. All right, in these last examples, we're going to write out the standard form, y equals a x minus h quantity squared plus k, and just take your numbers and put them in. So if they say the vertex is 2, 6, that's h and k, and the solution points would be 5, which is my x, and negative 21 is the y. So now we just have to solve for a. So I'd have negative 21, a. 5 minus 2 is 3, squared is 9. So parentheses 9 plus 6. So when I subtract 6, I have negative 27 is equal to a times 9. Divide by 9. And I get an a value of negative 3. So I should rewrite this as y equals negative 3 x minus 2 quantity squared plus 6. Standard form. So just write out your h and k equation, fill in the x's and y's appropriately, the h and k's appropriately, get your new a value, and then write it, because the problem is to write it in standard form. Next problem is DIY, so pause the video and try that one, and then come back for the answer. All right, so if you fill in everything, you know your h is the 6 and the 5 is your k. put in the 3 for your x and the 23 for your y, and when you solve, you're getting an a value of 2. So this is what the final equation would look like. This last problem, we're going to do it on the calculator, so we're going to type in the equation into the calculator, use the calculator to find the maximum, and then also find the 0. So I'll show you a trick for that. Okay, so on my calculator, I now have the equation typed in, and when I look at the graph, I know the football is going up. This is a height of 6 feet. That's where the quarterback released the ball. How far up and how far down the field? So we need to extend our window. Let's do 100 feet down the field would be 30 yards. 100 feet. Okay, so I can see it's coming back down. Now I need to extend my window up a little bit. So, how high do you throw a football? Maybe, let's say 30 feet in the air. Okay, so now I can kind of see the graph. I can go ahead and find second trace, calculate the maximum, and it will say get on the left, so move your cursor not too close to the top, hit enter, on the right, and for guess. So a maximum height of 29 feet, or excuse me, at about 30 feet down the field, it has a maximum height of almost 21 feet in the air. Now, a trick for finding where it comes back to 0, or the ground level where we could catch it, I'm going to put in a second line. Now, on some calculators, you can't see it, but on mine, you can see it go through in red. And what I'm going to do is calculate, so second trace, calculate an intersection. And do you want your first curve to be the quadratic? Yes. Do you want the second curve to be the y equals 0? Yes. Now, normally you have to move closer to it, but I know my cursor is closer to the intersection I want, and when I hit enter, it's about 65 feet down the field. So here are the answers that you can do. 20 feet in the air, 21 feet in the air, and 65 feet down the field.